Okay, so this is a question from Kinematics chapter. The question states that a fun drive in an amusement park runs between two spots that are 2 kilometers apart. And for safety reasons, the acceleration of the drive is limited to 4 meter per second square, and the rate of change of acceleration, which it has mentioned as jerk, which is the rate of change of acceleration, is limited to 1 meter per second cube. Now, if the drive can achieve a maximum speed of 144 kilometer per hour, find the shortest transit time of the drive between the spots. So, suppose the drive starts from point A. Now, it is important to note that initial velocity of the drive is obviously zero. It is starting from rest, but it should also stop. Finally, जो velocity होना चाहिए drive का, that final velocity should be zero. So the drive will accelerate as well as it has to retard and finally come to rest. So the total distance between AB points is 2000 meter or 2 kilometer. And these data are given to us. Maximum allowed speed is 40, maximum allowed acceleration is 4, and rate of change of acceleration has a maximum value of 1. Now, for minimum time, to cover this distance A to B in minimum time, the drive should attain maximum possible speed in the starting of the journey itself, right? So it is important that to minimize the time taken, we should try to attain the maximum allowed speed in the starting portion of the journey itself, and we should move with a maximum possible acceleration. सो स्टार्टिंग में ही हमको मैक्सिमम पॉसिबल एक्सेलरेशन से मूव करते हुए मैक्सिमम अलाउड स्पीड को अटेन करना है, तभी हम टोटल जर्नी टाइम को मिनिमाइज कर सकते हैं. एंड बिकॉज द फाइनली ड्राइव शुड ऑल्सो कम टू रेस्ट, सो सिमिलर प्रोसेस यहाँ पर एंड ऑफ द जर्नी में भी होना चाहिए. टुवर्ड्स द लेटर हाफ ऑफ द जर्नी क्या प्रोसेस होना चाहिए कि स्टार्टिंग में तो आपने एक्सेलरेट करते हुए मैक्सिमम स्पीड अटेन किया, बट फाइनली हमको रुकना भी है, तो मैक्सिमम स्पीड जो हमने अटेन किया था वहां से स्पीड को रिड्यूस करके जीरो भी लेके आना है फाइनली. ठीक है. सो बिल्कुल स्टार्टिंग पार्ट ऑफ द जर्नी में we will move with maximum possible acceleration and attain maximum possible speed, and in the last part of the journey we will retard with the maximum possible value of acceleration and reduce our speed from 40 to 0, right? But there is a statement in the question that maximum acceleration 4, it cannot be attained instantaneously. You cannot change the acceleration from 0 to 4 instantaneously. That is why rate of change of acceleration, this term is mentioned. So if you want to move with maximum possible acceleration, it will take some time for acceleration to increase from 0 to 4. You cannot increase or decrease the acceleration instantaneously, right? So suppose at the starting of the journey, we want to move with maximum possible acceleration, but it takes a certain time interval for acceleration to increase from 0 to 4. Okay. So once the acceleration is increased up to 4, we cannot go further. We cannot increase the acceleration beyond 4. So we'll be moving with a constant acceleration of 4 for some time. And then we will again reduce our acceleration and make it 0. And during this complete interval of t1 plus t2 plus t3, this complete time interval, our speed will have increased from 0 to 40 meter per second, which is the maximum allowed speed. Now, since the rate of change of acceleration is given as 1 and we need to attain maximum possible acceleration as soon as possible, that is why we are taking this slope of acceleration time graph over here to be the maximum slope, which is 1. Right? So since maximum acceleration is 4 and our slope of this straight line over here is 1, so this time interval t1 should also be equal to 4, right? So t1 is directly known, which is 4. And similarly, when we are reducing our acceleration from 4 to 0, then again this time interval t3 should also be equal to 4, right? So from here I can directly say that the value of t1 and the value of t3, these intervals are 4 seconds, right? Now, what happens in this first t1 interval? It is taking 4 seconds for the acceleration to reach from 0 to 4. But in these 4 seconds, acceleration is obviously not constant. dA by dt is 1. If dA by dt is 1, it means acceleration is equal to t. So if acceleration is equal to t, you can equate acceleration as dv by dt, and there's a very easy integration involved over here. You will get a velocity of t square by 2, right? This equation holds only in the time interval of 0 to 4 seconds. So velocity at any time t in this interval is v square by 2. Again, if you write v equal to dx by dt and again integrate, you will get x equal to t cube by 6. So when this variable acceleration, this after this 4 second, at the end of this 4 second, what happens? What is the velocity? We get the velocity as 8 and the displacement of the particle or the drive as 32 by 3 meters. So you can look at this velocity time graph over here. In this 4-second interval, the velocity has increased by 8 meter per second, and the displacement, which is the area, this you can see this shaded area over here, this area will be 32 by 3, right? And after t1, the acceleration becomes constant for certain interval t2, right? This acceleration becomes constant for certain interval t2, and then we will reduce the acceleration such that the particle attains a final maximum allowed speed of 40. So we'll continue this in the next page. Okay. So from this AT graph, now T1 is known to me, which is 4 second. T3 is known to us, which is 4 second. Now the rate, area under this acceleration time graph, this total area will give me the change in velocity. Now what is the change that is required? We require a change of 40 meter per second from 0 to 40, right? So this area is half of this base. Okay, this base is T1 plus T2 plus T3 plus this length, which is T2, right? Simply the area of a trapezium. So half into sum of parallel sides into distance between them, which is 4. And this area should be equal to 40. So since T1 and T3 are 4 seconds, you will get the value of T2 as 6 seconds. That means the particle is undergoing a constant acceleration of 6 meter per second square for the time interval of, sorry, a constant acceleration of 4 meter per second square for a time interval of 6 seconds, right? Now, in this time interval T1, T2, T3, the total distance traveled or the total displacement, you can call it either way because the motion is unidirectional. So, the total distance traveled by the particle at the end of this T1 plus T2 plus T3 is simply the area under this velocity time graph. Now, what will be the area under this velocity time graph? See, first this area was 32 by 3. So this we have added 32 by 3. Then since the acceleration becomes constant for the interval t2, the velocity time graph will be a straight line, right? At the end of t2 interval, in the t2 interval, what will be the gain in velocity? In T2 interval, the area under acceleration time graph gives me the change in velocity. So you can see that this area is 4, which is the height of this rectangle, multiplied by T2, which is 6. So 24 is the area for this interval T2. So here the velocity was 8 meter per second at the end of T1 interval, and the change in velocity further is 24, right? So 8 plus 24 will give me 32 meter per second. Okay, so at the end of T2 interval, our velocity will be 32 meter per second. And at the end of T3 interval, the velocity should finally be equal to 40 meter per second. So what is the total distance? First term is this 32 by 3 meter. Second will be this area under the velocity time graph. So simply we can again write by using the equation for area of trapezium. Half of sum of parallel sides, this will be 8 and this will be 32 multiplied by this distance, base distance, which is equal to T2, which is 6. So half into sum of parallel sides 8 plus 32 multiplied by 6. And this area, this portion area, this I have written uh, by considering that, see, because this area was 32 by 3, the shaded portion. Similarly, this above shaded portion, you can see this area will also be equal to 32 by 3 because the variation of acceleration is same, right? The rate of increase in acceleration and the rate of decreasing acceleration, these two slopes are same. Therefore, this area should also be equal to 32 by 3. So instead of integrating, it is easy to calculate this remaining area is this total area under the rectangle, this total area which is 40, this height is 40 multiplied by T3, this length is 4. Okay, so from the area of this complete rectangle, I am subtracting this shaded area which is 32 by 3. So I'll get this remaining area over here. So what will be this remaining area? 40 into 4, this is the area of this complete rectangle, minus this shaded area which is 32 by 3. Okay, so I'll get the total distance traveled to be 280 meters. So what happens is the particle accelerates and it attains a maximum speed of 0 to 40 in the total time interval of t1 plus t2 plus t3, which is actually a total of 14 seconds. And the total distance it travels is 280 meter in the beginning part of this journey. Now, since the final velocity has to be 0, so just by symmetry, I am saying that at the end of the journey, there will be a similar retardation process, and again the particle will take 14 seconds and travel a distance of 280 meter and finally come to a rest. So the remaining distance of 2000 was the total distance, and the minus of 280 in the beginning and minus of 280 in the later half. So the remaining 1440 meter, this distance will be covered with a constant velocity of 40, because we cannot increase the velocity beyond 40, right? So first 280 meter is covered with a variable acceleration part. Then 1440 meter, this distance is traveled with a constant velocity. And at the end, again, it travels a distance of 280 meter in 14 seconds interval. So what will be the total journey time? In the beginning, it is 14 seconds. Then it is moving this distance 1440 divided by 40 will be the time taken for moving with this constant velocity part. And again, at the later half, at the last part of the journey, it is again taking 14 seconds to retard and finally come to a rest. So the total journey time comes out to be 64 seconds, right?